The second data set that we'll be working with in our data acquisition series is from Yahoo Finance. So Yahoo Finance is also a Python API that allows us to access historical stock market data. The stock market is something that's very familiar to most people, so we think it'll resonate with you. And it's a very easy data set to work with. So before we get started, let's head over to the Yahoo Finance project page. So here's the project page, similar to the NFL play-by-play data project page. It's a little bit more information than what you'll get from these videos. So feel free to navigate. I think there's a couple of links. There's a legal disclaimer, some quick start modules, and so on. So feel free to browse this at your convenience. Otherwise, let's get started with pushing this data to our PostgreSQL database. The first thing we want to do is launch Jupyter Notebook from Anaconda Navigator. So scroll down until you see Jupyter Notebook and click Launch. This will open in your default web browser, which brings you to Jupyter's landing page, which is a very basic interface where it's just a simple file structure where we'll store our Python scripts. Click New, Python 3, and this will bring us to a blank code editor. It's a very simple interface here as well. It's structured by the use of cells. So basically all this means is we will create smaller blocks of code and stick them in individual cells. If we put too much code into an individual cell, it gets hard to read. So this just makes it a little bit easier. Basic navigation to run an individual cell, you're just going to click into the cell you want to run and press Run. If you want to run everything below a specific cell, you're going to click into your starting point and click Cell, Run All Below, or you can click Run All to run the entire page. If you want to insert a cell above or below a specific location, click into the cell that you want to insert above or below, then click Insert. Insert cell above or insert cell below. If you want to understand if your code is running or is remaining idle, you're going to look at this empty circle in the top right. If it's empty, it means it's idle, and if it's solid, it means it's running. Let's give this file a unique name so we don't lose track of it. So we are running a, let's call it just push Yahoo Finance to PostgreSQL and click rename. First thing we want to do from here is we want to install a couple of libraries, and we will use Python's standard installer, which is pip install. So let's start with the Yahoo Finance library. So pip install yfinance and press run. It'll take just a second. Okay, it's complete. And the next one we want to install is the data reader, which will allow us to read the Yahoo Finance library. Without it, we will not be able to access it. So let's pip install pandas_data reader and press run. It should be complete now. Yep, we are done. Now let's get rid of all these output messages and go to kernel, restart, and clear output. You then restart and clear all outputs, and this will give us a little bit of a cleaner interface. There we go. The next thing we need to do is we need to import all of the packages and libraries that we're going to use, including those that we just installed. SQL Alchemy will allow us to push a data set, a data frame into our PostgreSQL database. Pandas is the standard data analysis package that comes with Python. It's where you work with data frames, which is Python's powerful version of a table, just like in Excel, rows and columns. The data reader is what we just installed to access the Yahoo library. We have to import the Yahoo Finance library. And we're also going to import the date time package as well, which will allow us to run some date math using like the current date minus 5 years and things like that. So let's run this as well. That is complete. Now let's have a look at some test data. So the way this Yahoo Finance library works is we have to call a specific function. We can pass it to a variable, which is, we'll just call it test data. So it's just an empty variable, test data. We need to use the data reader, which you see this PDR, and you can see here we identify the data reader as PDR. It's just like an alias name. Basically makes it easier than calling kind of this whole thing here. We can just say PDR. And then we're going to use a standard Yahoo Finance function, get data Yahoo. Then the way it works is, unfortunately, we cannot just read the entire data set. We have to pass individual stock tickers into this get data Yahoo function, and we have to pass a start date and an end date so we know exactly how far back we want to look for that specific stock ticker. So let's just look at some sample data, and we'll work with the Google stock ticker, and we'll look at this year, January 1st, 2023 through December 31st, 2023. So to look at this, we can just print test data. Okay, this is the variable that's getting the data from Google. So let's run this and see what we get. We forgot something. So let's actually insert a new cell right above this. So we're going to insert a cell above. I forgot to apply the data reader override. It's the first step. So we have to utilize the data reader that we just installed, because if we do not do that, the default data reader will not work with the Yahoo Finance library. So now we should be able to run this code. So I just pasted this here, yf.pdr_override, and I ran it, and we should be okay to run this next one now. Yep, there we go. So here is what the data, the Yahoo Finance data looks like. You can see we have an individual record for each day. Then we have some different metrics around that specific stock ticker. So we got the open for that day, we got the high price for that day, we got the low price for that day, the close, the adjusted close, and how many shares were sold that specific day as well. And this is just for Google because we specified Google as a ticker that we wanted to select. Now, one thing we want to do is, if you think about it, we're going to work with a lot of tickers, thousands of tickers. Nothing in this data set indicates that this is specific for Google. So how will we know as we work with more data, how will we know that this belongs to Google versus Apple or Netflix, right? What we can do is we can actually add a new column every time we look at a specific stock ticker to this test data set. We could call the new column symbol, and we can populate the symbol column with the ticker that we're reviewing. So let's do this. Let's rerun this code, and let's see what we get. So we get the exact same data, except for this time we get a new column at the end that says Google. So this is how we will differentiate different stock tickers from each other when we start to compile the final master table containing thousands of stock tickers. The next thing we want to do is we want to think about how much data do we want to pull through. We have thousands of stock tickers, and we have hundreds of rows of data per year if we run it at the daily level, right? So right here, for example, we probably have about 250 rows for just Google for just 2023. We have thousands of tickers, and we're going to be looking back 5 years. So how do we want to handle that? I would recommend that we collapse these down so we have one row per month. So to do that, we will use aggregation. And aggregation is basically just going to look at your 20 days per month, and it's going to collapse it down to one row per month. Then you can specify what elements do you want to see aggregated how. So, for example, your open price Doesn't make sense to look at the highest open for that month. It makes sense to look at the first open for that month. The high price, however, does make sense to look at the highest price. The low price makes sense to look at the lowest price. The close price makes sense to look at the last price of that month. Same with the adjusted close. And the volume would make sense to look at the total number of shares sold, meaning the sum across the entire month. So how we can handle that with aggregation is we can create that definition. So for example, we can say, let's create a custom aggregation definition in this dictionary. So we've got each of the columns above outlined, right? So you've got here's your columns. You've got your open, high, low, close, adjusted close, volume, and symbol. You can see each of those columns are reflected in this dictionary, and we've specified how we want to aggregate this information within that one singular row for each month. For the open, we want to pick the first value. For the high, we want to pick the max value. For the low, we want to pick the min value. And for the close, we want to pick the last value. Same with adjusted close. The volume, we want to pick the sum, and the symbol, we're going with the last. We could pick the first, the last, the min. That doesn't matter because every record has Google printed out. So now we need to rerun that data set using this definition. So we're going to pick the test data. We're going to create a new data set called test data resampled. We're going to pick from the test data set that we defined above, right? Remember here we said test data is going to be this exact data set. We're going to have each day the open, high, low, close, and so on, including the symbol. So we're going to read from that data set. We're going to resample based on the first column's date column, and we're going to use the month. So we want to roll it up at the month level. We want to aggregate the data, and we want to aggregate it based on the custom aggregation definition that we just defined here. Okay? Now let's print that out. Test data resampled. See what we get. All right, so now we have only 12 rows of data. We have one row for every single month, and we've got the first value from the open column, the max value from the high, and so on. Exactly how we defined it. So now we just took 250 rows, turned it into 12 rows. Now we could build out some history over a 5-year time period, and we could start to do some analysis based on this. Okay, the next thing we want to do, as I mentioned, we have to treat each individual stock ticker separately, right? So I personally do not want to write this code 10,000 times, one for each stock ticker. I want to find a list of stock tickers, and I want to loop through that list and run this same code for each specific stock ticker. Then I want to load it to a data frame. Then once we're complete, we want to take that data frame and we want to push it into our SQL database. So how can we do that? We need to find a list of stock tickers. We could do that from a file stored on a Nasdaq website. So this text file coming from the NASDAQtrader.com includes a list of stock tickers along with a couple of other attributes. So we can read this string and store it into a variable. Then we can use the read CSV function, and we can then read this file in. We could separate the columns based on the pipe delimiter, because it's a text file, right? So it has a delimiter. It could be a comma, could be a pipe, could be something else, could be a tab delimiter. And then we could store that into a data frame. extract the stock ticker, store it in a list, then we can use that list to loop through and run all the code that we just went through. So how do we do that? Just like this. So we're going to create a data frame, Nasdaq symbols underscore DF. We are going to read the CSV into this data frame based on this file path, and we are going to split it on a pipe delimiter. Then we are going to take this data frame and we are going to extract the symbol column from the data frame and store it into a list. Then we could print that list and see how that looks. Let's have a look. You see a list of stock tickers. There's going to be thousands of records here. You can see how much we're scrolling, and we don't even get through the C's. So it just goes kind of on and on and on, right? And dot, dot, dot here at the end. So now we have a list that we can use, okay? The next thing we need to do is we want to create a look back time period, because we don't want to hard code date values, because let's say we want to run this each month. We want to make sure every time we run it, we can actually just read in the current date and look back 5 years. So this is where the date time Python package comes into play. Okay, so we can create a variable, start date and end date. Then we can look into the date time package. We can read today's date. Then we can apply some date math. Basically, we could subtract out 5 years, and each year is defined as 365 days. Then we could do a little bit of formatting here, year, month, day. We do the same thing for the end date without the date math, because we don't care about a look back, right? So we just care about the current day. So we're gonna run from today back to 5 years. That's our starting date. Then our end date is today. Okay, so let's run this. Doesn't print anything out. We can do that here. So let's run the start date. We get 12/27/2018. Looks good. Today's 12/26/2023. Let's look at the end date. And we get 12/28/2023, or I'm sorry, 12/26/2023. So that looks good. So now we've got a list of stock tickers, we've got a start date, and we've got an end date. We now need a home for all this data, right? We can, like I said, we have to loop through thousands of stock tickers. We don't want to create thousands of data frames. We want to create one data frame, then we want to dump each stock ticker's results into that data frame. So let's create an empty data frame that we'll use in a couple of minutes. That's very easy. We're going to create a data frame called historical data underscore DF. You can see we're creating the data frame right here, pd.dataframe. We're not passing anything into it. We're not passing a CSV file. We're not passing a data set, a list, nothing. Then we're going to print it. It's empty, as we expect. So now what we need to do is we need to bring all this stuff together, right? We've got our list of stock tickers. We've got our Yahoo Finance library. We know how to access the data from it. We know how far we want to look back. We have our final destination data frame. So now we just got to bring it all together. Okay. So we're going to use a loop, basically a for loop, to run through all these different stock tickers. Then we're just going to take everything from above and just pass it into the loop. So loop is just going to basically start at the top of the list, the very first stock ticker that we see here, right? So if I scroll back up to the top of this, it's going to start with AACG. Then it's going to run through the code, store it into our data frame, move on to AACI, store the results into our data frame, and so on. So the way we run a loop in Python is we use a for loop. So we just say for something, in this case, tickers, in our Nasdaq symbols list. So we have a list, Nasdaq symbols. In that list, we have a ticker. Then we want to do something. We want to try to execute some code. Sometimes it doesn't always work. So if it fails, we need to tell it what we want to do. So we want to create an exception. So it's going to try to execute it. If it fails, it's going to move on to the exception. Sorry, except. So except, exception. And what do we want to do with this exception? I want to continue. I do not want to abort the process, because if we abort the process, then we just wasted our time, right? We don't have a final data frame that we can use. What's going to happen, what's going to cause a failure is if we have a stock ticker in our Nasdaq symbols list that is not in our Yahoo Finance data set. So we're just going to say, okay, if we can't find this ticker in this data set, we're just going to keep moving right past it, okay? So try is where we're going to put all the code that we just went through up above, where we're going to kind of piece it all together. If it fails, it's going to move to the exception, which is just to continue on to the next ticker. So what we want to do, let's just start to pluck pieces of code that we just created up here, right? So the first piece of code is we want this. And we're going to we're just going to paste this right into our try block of code. Python is very specific with indentation. So when you saw I pasted that in there, this was all the way back here. That's not going to work. You have to line it up. Indentation is used to know when to move on to to escape out of that loop. So basically what we're going to do is we're going to get rid of test data because we're no longer looking at test data. We're going to be looking at real data. We're going to continue to use the data reader and the get data Yahoo function. In this case, we do not want to hard code Google. We want to pass dynamically the ticker that we're retrieving from our loop. And our start date, we do not want to hard code the start date and the end date. So we're going to pass our start date variable and our end date variable. Just like that. And then our new column that we're going to add, again, we're not going to hard code it, right? Because we're going to want to do it for every single ticker we deal with. So we're just going to read in the ticker name, and we're going to pass the ticker into the symbol column. Then the next ticker that we come across, everything will reset, and then we'll get the next ticker added to the symbol column when we get to that next ticker. We also need to create our custom aggregation and our resampling of the data at the month level. So let's also do that. All right, so here's our custom aggregation. And it's the same as before. This is also the same thing as before. In this case, we're going to use the data underscore resampled is the variable name that we're going to use. I think previously we used something different, maybe test data resampled or something. We use test data resampled. So in this case, we're just going to use data resampled. We're no longer working on our test. We are going to also look at the data set, not the test data set that we looked at before. We're going to, again, apply the resampling at the monthly level. We're going to aggregate the data, and we're going to read in the custom aggregation definition that we just defined here. In theory, we could probably use the same one from above. But we're doing it this way just so you can, if you want to skip the sections above, you can just paste this in here. It should not hurt anything. The next thing we want to do is we want to append each ticker's data set to our empty data frame, and we do that with a concat function. So a concat function is just taking two separate things and merging them together into one bigger item. Similar concept exists in SQL. We'll deal with that in SQL. Here, we're just taking your new data frame, your aggregate data set here, this data resample data set, which is your monthly view. And for each ticker, because we're still inside that individual loop at the ticker level, we're going to basically append this data resampled to our empty historical data frame, right? The first time we do this, it'll no longer be empty. So we'll have that, what was it again? The AA, let me scroll up here. So as soon as we process AACG, our empty data frame will no longer be empty. It'll have the results from the AACG stock ticker. Then what we'll do is we'll move to the second one. Then we'll just keep appending to itself, right? So that's why we're not changing the name of it. We're just going to continue to basically just append the data, right? So our starting point is the historical data frame, and we're going to append our new aggregate resampled data for each stock ticker to itself, basically, is what we're going to do. And finally, we want to give ourselves a cue of how we're progressing through this loop. So we can create a print statement. So when this try section here succeeds, right? So we're still working within the scope of each individual ticker. So when we complete this process for each ticker, we want to just create a little print statement that just says we just downloaded data for that specific ticker. So we create a print statement surrounded by double quotes, and we're just going to say, let's just say appended. Now let's just say download data for, then we could pass a variable into this. So we can actually pass the ticker name into this string. And you can do that with these brackets around the ticker variable. However, we have to create a special string. This string, you can see this ticker is just, it's all red, just like everything else. Basically what this means is it's going to just print out download data for ticker, not download data for that specific ticker. It's just going to print out just how you see it. If you want to pass a variable or some kind of a function into this string, you need to just preface it with an F. So you see when we preface the string with an F, what we get here is we get a black kind of portion of the string. This means it's dynamic. So now it'll process for every single ticker. You'll see, I forgot what the name of it is again, AACI or something like that. So we'll say download data for AACI. That's it for the build out of our final data frame that we will ultimately be sending over to our Postgres database. Only thing we'll do remaining from this point is when we are complete with all of the stock tickers, we're going to kind of come outside of this loop now. So we'll give ourselves a couple of lines. We'll back our indent up to the start of this cell. And we will say, let's print out, this dot head means print out only the first 5 records of that data frame. So this is, at this point, this is now our final data frame that contains all the data for 5 years rolled up at the monthly level for every single one of the stock tickers in that Nasdaq list. It's going to print out just the first 5 records just so we can see that we're done. We can also do something like print process completed, right? So it'll say process completed, and then you'll see your 5 records. And that should be it. So we're going to go ahead and we're going to press run, and you can see it's starting to move, right? Download data for AACG, download data for AACI, download data for AACIU. This means it has already executed this entire script for AACG and AACI and AACIU. However, we see this failed one here, right? This is the exception. Basically, it means it could not find AACIW in the Yahoo Finance library. So again, because we put this exception process here, that's okay. It's just going to move right past it. So, and it's going to move on to AADI. We're going to let this run. It's probably going to take about 20 to 40 minutes, depending on your computer. When this is complete, we'll come back, and then we'll actually take this final data frame and we'll push it over to our Postgres database. See you in a few. All right, we're all set. Now we're ready to take this final data frame and push it into our PostgreSQL database. First thing we need to do, which you may have already done if you downloaded the NFL play-by-play data to your Postgres database, but we need to establish that driver that connects to Postgres. So all you're going to do is one more pip install. And we're going to pip install this PSYCOPG2 connection. Hit run. It'll take a second. Okay. Next thing we need to do is we need to establish the actual connection string itself, which is found just right from your NeonDB dashboard page. So you're going to create a variable engine, and you are going to establish your connection string here, which you can find from Neon. So let's just start over here. Let's come in here. We'll Google NeonDB, and it will bring me to the Neon website. I'm going to log in. I'm going to enter my project, my dashboard, scroll down to your connection string, click the little eyeball to make sure that you can see your full connection string, clipboard to copy it, then you come back. And what you're going to do is you're just going to insert that connection string into this create engine function. This creates your connection, okay? Then we can push that final complete data frame to SQL using the toSQL function. So we're going to take our final data frame, which is historical data df, to SQL, give it a table name, Nasdaq price history. You want to pass the connection string into this function. So you're going to pass engine. If the table exists, you need to tell it what to do. You can either overwrite the table, and if that's the case, you use replace, or you can append data to it. We want to just replace the table. Then you have to define your batch size. It's called chunk size. We use 5,000 records. If you start going more than that, it's going to end up timing out. You're going to run risk of connection interruptions. So I've used this 5,000, and so far I've had no problems with it. The other thing we want to do is we actually want to bring a reference data in from that Nasdaq text file that we imported that has a little bit more information about each specific stock ticker. So let's actually pull that in as well, and we define that data frame up in a prior step. We'll go up to that in a second. But it's going to be the same thing. We're going to read that data frame, we're going to push it to SQL, and it's going to be, the new table is going to be Nasdaq stock tickers with the same connection string. We're going to replace, and we're going to follow the same chunk size. So if we come up here, I'll show you where that was. So right here, when we read in this text file, one of the steps was we stored it in this data frame here using this pipe delimited separator. So now we have two data frames here, and then we can do, again, we can do print completed. So now we've installed our connection driver, we've established our connection string, and now we're pushing two tables into Postgres. And we can hit run, and this will probably take a couple of minutes, and if that's the case, I'll step away and I'll come back when it's complete. Thank you. All right, we're complete. Looks like everything's been pushed over to our PostgreSQL database. So let's go check it out and make sure that is in fact the case. So come back over to Neon, and along your left navigation pane, find tables. Should take a second, but it will refresh, and you should see two new tables. Give it one sec. It's taking more time. If it's taking time, just hit the refresh button. There we go. So here we are, Nasdaq price history and Nasdaq stock tickers as we expected. Let's make sure the columns exist. The price history has all the same columns we'd expect to see, including the new symbol column that we appended. And Nasdaq stock tickers also has a handful of columns, including some various categories and flags, and of course the symbol column, which is how we will establish a connection back to our stock price history table. So that concludes this lesson. I hope you enjoyed it, and we'll actually start to work with this data a lot more in upcoming videos. Thank you very much. Thank you for watching. I hope you enjoyed the video. Remember, subscribe to our YouTube channel for free learning opportunities. Visit our website at datacoaching.io to set up a free personalized consultation We'll be offering private, group, and corporate options, and follow us on LinkedIn for special announcements. Thank you.